All right, so sometimes you want the values of a data frame but not the data frame representation of it. So this would be, so if we did df.score command, we're going to get this series. But if we just want the values, say we want to do something where we don't want those indexes, we can use this values command. I'll try to show an example of that at some point. Another cool thing we can do, we saw apply a minute ago, so here's a little more information about that. Apply can work with a function, but it can also work with this kind of lambda function, which gives us a way to use variables. So we can have a function f, which is a function of x. So we say lambda x colon, and then we say x. In this case, we can see it do a max minus min. So this would be x.max and x minus min. This would be relevant to, say, a list or a series. And because Python's dynamically typed, we don't have to know exactly how we're going to use this function. As long as whatever we're running it on has a max and a min, then it will work. We can also have a second function called value counts, which gives us the value counts of a data frame, which I don't think we've seen, so I'm going to show you that right now. I will copy this. So value counts is really useful. What it does is gives you it outputs a series, but the values are on the left, and then the counts that each of those values appears is on the right. So if you look in this column, you see there's a lot of ones. In fact, there's 18 of them. There's 6 2s, there's 6 zeros, and 1 3. So this is a really handy way to summarize a column of a data frame. So we're going to we just made a function that uses that value counts, so we can apply it in different ways. So we're going to have f and g, and so we're going to take here a set of columns. These are the numeric columns, which are specified by that list that we created up above. And we're going to apply that function. So this is going to get the max minus the min value for each of those columns. So it's the difference between the most and the least value for all the students. So I showed you this already. This is the same function we did. It's just this is using the dot notation, and this is using the bracket notation. And then to run value counts on each column, this is actually really useful, because typically value counts only works on a single pandas series, a single column of a data frame. If we want to run the value counts on all the columns, we use this apply. We set this function here, and then use apply, and this allows us to get. It basically does value counts and merges the output. So we have. This is actually not the subject ID. This is just the score 0 through 3, and we have the value counts for each of these. So we can see, for example, that most of us don't have, or most of you don't have any experience with Perl, which is okay. And with Python, there's more experience, and etc. Right? We can see get a sense of the data really rapidly like this. A couple more things to cover today. So one is sorting. Oftentimes you want to sort your data frame either by the index or by values in the data, and this is really really handy. So if we want to sort the index, we just use this command df.sortIndex, and this would be, we can either sort actually the indexes or the columns, and they both use the sort index function. So in this case, what's happening here is the subject IDs are stored as strings. So these are being sorted alphabetically. So 1 comes before 2, even though these numbers aren't. So that's something to keep in mind. That's just because the type of index we have is not numeric because of the way we imported this data. Remember when I said that because we imported it and when we had to transpose it, all of those values were already stored as strings. So we could convert the index to an integer if we wanted to numerically sort it. So we have ascending equals true and in place is false. So we are not, if we wanted to sort and change the data frame itself, we could say in place equals true. Now if we wanted to sort the columns, we can also do sort index, but we're going to say axis equals 1. And now we've sorted the columns. You can see that M comes before R and P, so we've sorted these columns. If we want to sort by the values, we use df.sortValues, or whatever the name of the data frame is, .sortValues, and then we can pass a list of columns if we want to do a like in Excel, if you want to sort by multiple columns, you can sort by the column A and then by column B and then by column C. You can do that here. Here we're just going to specify one column. So we're going to use the, it's going to sort looking for a, we can do it by, we can sort the columns, but we want to, here we want to sort the rows. By, so we're going to have axis equals 0 using this column. We're going to have it be descending, not ascending, and we're not going to do it in place. So now we've sorted by MATLAB here. And if we wanted, we could do, I can copy this. And I can, so one thing in the Jupyter Notebook, if you highlight something and then type like a parentheses or a bracket or a quote, it will automatically put it around it, so that's really handy. Let's do this. So we can do, so here it's going to sort by MATLAB and then by R. So we can see that we have 3, 3, 3, 3, and then 1, 0, 0. So these are now sorted first by MATLAB and then by R. And same thing, we can see it here. But we did not change the data frame. So if we wanted to change the data frame, we'd need to set in place equals true. Another thing we can do is we can use this map function. So in fact, I'm going to so we have these data types, but let's say we wanted to change whether the person has a computer or not to a Boolean value. So right now it's just yes or no. I think for everyone in the class it was yes. But we can make a dictionary, which I'm going to call YNTF. So yes, no, true, false. So yes is going to map to true, and no is going to map to false. And so I'm going to change that column and then use this map function. So this map function or method will map the value in the key to the value here. So if we do that and then look at data frame, we can see that we now have true where it was yes. And again, yes is in quotes because it's a string, but true and false are not in quotes because those are special words. They have special meaning. They're Boolean special variables. And so when we do that and then we look at the data types, we see that that column is now Boolean type. Finally, if we have if we have null or values that are not filled. So in fact, let me go up to, let me see if I can get an example from earlier. Let's do this one. We have result. So, okay, just save that for a minute. So one thing we can do is we can create a new column called score bash, which wasn't in the original data frame. And if we look at the data frame, we see we have this column score bash, which has no values in it. So if we wanted to fill that with zeros, we can do df dot fill na and replace that. And now we've replaced that. So now we have zeros in place of where it was null. So, oh, that's the wrong result. Let me go back. Just want to give another example here. Yeah. Let's do this one. Okay. I'll call it something else. Call it result 2. Get myself into trouble because we're going out of order here. Let's do okay. If this example worked, I would just show you another way you can, just another example of doing fill NA. So we're basically taking any of these NaN values and filling with 0. The example's not working because we reuse the names throughout the notebook, and so now at the end of the notebook it's not working. So I'll fix that. And another one that we can do is, let me see if this works. Okay, so there's another method that we can apply to the data frame, which is null, and this will tell us this is kind of a way to, if we wanted to check if there was null values in our data frame, this would work. So we've created this. I went back and remade this column, so I overwrote the zeros, and now we have nans again. And if I run is null, I see that that last column is getting true for all those values. So then when we can fill it, and now we've got zeros again. So I'll add that later. But that's a lot more Pandas stuff today. So we've covered a lot. If we go back to our, just to kind of orient ourselves. So we're going to come back and do more Pandas in not next week, but the following week. We'll do time series and group operations, and that will kind of cover the rest of the main functionality of Pandas. But next week we're going to take a break from Pandas and do plotting. So we're going to use Matplotlib, Seaborn, and actually going to take the interactive visualization from lesson 18, and that's going to go into lesson 14, which will allow us to spend more time doing some more statistics and machine learning and stuff in lesson 18. So lesson 18 is not going to be interactive visualization anymore. It's going to be machine learning and some various Python statistics, things that we want to do. So that's where we're at. Any questions? Great.